All right, today we are on lesson 3, variables and expressions. I am here, sorry, my voice is completely off and my hair is goofed up, and I got my bottle of orange juice. Been battling this upper respiratory infection for I don't even know, a week. All right, we are going to start off with a graphic organizer about algebra. There's a language of symbols using variables. A variable is just a symbol. It's usually a letter, it represents a number, n, x, something like that, okay? So we're going to first look at the math meaning of variable, okay? And the math meaning of a variable is a symbol, usually a letter used to represent a number, okay? A symbol usually a letter to represent a number. I don't know why they give you such little space to write all this in, because I definitely cannot write that small. A symbol, usually a letter, used to represent a number. And the everyday meaning is to add, change, or vary. So okay. So, for example, in everyday life, if you had a variable, it's almost like a variety. It's a different, like a variety of foods. If you like a variety of foods, you like pizza, you like hot dogs, you like popcorn and tacos and things like that. Okay. So to add a variable is to add a change. So if, let's say I'm trying to lose weight and I've hit a plateau where I'm just not losing weight anymore, then I might change something up. Maybe I'm going to change my workout. Maybe I'm going to start working out and I haven't worked out. Okay, that's a variable that I can change to see if it helps me to lose weight more. Okay, if you're getting an upset stomach with what you're eating, okay, maybe you cut out sugar for a day. Maybe you change that variable to see if that stops the stomach aches. All right. So an example of a variable is x and y, a, any letter that you can plug in for a number. And a non-example is like 3, 6, -10. Okay, those are non-examples. You don't want to use numbers as a variable. That's not, a variable is like an unknown. So if there's something you don't know, you just kind of plug in a letter. So if I do x, this is going to happen. Okay? And you can plug in a variety of things, all right? So if you're in a bad mood and you can put in x, and x could be, I could do x if I'm mad. I could take a run and get a result. I could punch a punching bag and see what that result is. I could talk to the person and see what that result is. I could yell at them. I could hit them. Tons of things I could do. Those are all variables that could get different outcomes, right? So a variable is a letter of something that we just don't know. All right, in our real world link, a box contains an unknown number of markers, and there are 2 markers outside the box. Total number of markers represented by the bar diagram. So they give us this whole big bar here, and 2 markers are outside the box. So it says, suppose there's 14 markers in the box, find the total number of markers and explain your answer. Well, if there's 14 markers in the box, okay, and there's 2 outside the box, this isn't that hard, 14 plus 2 is 16, right? That would be 16 total markers. But if you didn't know what was here, this unknown, you would write it x plus 2 equals, and then if they told you there were 16, you could write 16. And then you would just have to figure out what plus 2 equals 16. And then you would figure out that that is 14. All right? So a variable is just something that you plug in for an unknown. And if there's 14 markers in the box and it says that there's 2 outside the box, then you know the total is 16 markers. All right, mathematical practices. We're going to have to think a little abstractly today to get this concept down. Definitely going to have to do that. Going to have to persevere with problems more than likely, okay? Expressions can be kind of difficult. Alright, let's go on and see what we got. Algebraic expressions contain at least one variable in one operation. For example, n plus 2. Okay, the letter x is often used as a variable. To avoid confusion with the symbol x, there's other ways to show multiplication. So once you start getting into algebra, you're going to start showing you x with this dot. I'm going to start showing you it with parentheses or a number next to a letter. If you see a number right next to a letter, that's automatic that it's multiplication. Alright, so variables in an expression can be replaced with any number. Once they've been replaced, you can evaluate or find the value of an expression. So if it's telling you to evaluate something, it's telling you to find the answer. Okay? I don't know why they just don't say solve it. That would be a lot easier, wouldn't it? So here they give us an example. 16 plus b if b equals 25. So if b is 25 and 16 plus b, then all we have to do is take whatever b is, 25, and plug it in. And then do 16 plus 25. And our answer would be 41. That's how we evaluate. If we know what that expression stands for, or that variable stands for, then we can evaluate it and solve it. Evaluate x minus y if x is 64 and y equals 27. So basically what they're doing is telling you to do 64 minus 27. Okay? So they plug in 64 for x, plug in 25 for y, subtract them, and when you evaluate it, you would get 37. Remember, evaluate means to solve. And our objective today is to solve these expressions and equations. Evaluate x if x is 1/2. So 6 times 1/2. Okay? Remember, any whole number to make it into a fraction is that over itself. So what they basically did here is they did 6 over 1 times 1/2. And remember, when you multiply, you just multiply straight across, right? So they get 6 over 2. And then that's improper fraction. The numerator is bigger than the denominator. So we divide 2 into 6. And we get 3. That's how they got that 3 right there. Okay? So if evaluate each expression, so solve it. If a is 6, b equals 4, and c equals 1/3. So for letter A is 6, a plus 8, so 6 plus 8 is all you have to do to solve that. So 8, 9, 10, 11, 12, 13, 14. A minus b. So again, a is 6, so plug in 6 for a. B is 4, plug in 4 for b. 6 minus 4, 2, good. A times b, remember this dot now means times. A is 6 times b is 4. What is 6 times 4? Good, 24. And 9 times c, remember if a letter is right next to a number, it automatically means multiply. So 9 times 1/3. And remember, if we have a whole number, we just put it over 1 and multiply straight across. So we have 9 times 1 is 9, over 3 times 1 is 3. That's an improper fraction because the numerator is bigger than the denominator, so we have to divide. And we would find that 3 goes into 9 3 times. So our answer for this one is just 3. Okay? All you're doing is taking whatever this letter is worth, plugging it in and solving it. Alright. You need to pause. I hope you did it already because I'm erasing it. Move on. Okay. When we evaluate multi-step expressions, okay, we are going to replace a variable with the correct value and follow the order of operations. Remember, we've already done order of operations. So they give us an example of 5t plus 4 if t is 3. So what they're saying is 5 times t, which is t is 3, so 5 times 3 plus 4. And then we know that we always multiply and divide first, then add and subtract. So 5 times 3 is 15, plus 4 is 19. They give us this other example down here, and they threw in a square. Evaluate 4 times x squared if x is 1/8. So remember, you have to do 4 times 1/8 squared, which we have to figure out the squared first. And remember, it's not 1/8 times 2, it's 1/8 times 1/8. And they did that for us. Okay? So 1 times 1 would be 1, and 8 times 8 would be 64. That's how they got 1/64. It's not 1/8 times 2, it's 1/8 times 1/8. That little square tells you how many times to multiply that number by itself. Then they did 4/1 times 1/64, and they had to simplify it. So they did times, and they would have gotten 4/64, and then off to the side they would have divided. That's how they got 16th. So they got 1/16. Okay? Alright, down below. Evaluate 10a plus 7 if a is 1/5. So here they want us to plug in some numbers. They've got 10a plus 7 equals 10 times a is 1/5 plus 7. But this, yeah. So over here we would write 10/1 times 1/5, right? Because we have to multiply before we can add. And we would get 10/5, which is an improper fraction. So how many times is 5 go into 10? Good. 2. So that would be 2. So they ended up, they got a different number than I got. Hang on a minute.